Hello, this is mathjazz from Almost Cool. This is our fifth video in our series of videos on derivatives. Our topic today is the chain rule. The chain rule says that the derivative of f of g of x is equal to f prime of g of x times g prime of x. If we let f and g be differentiable functions, and we plug f of g of x into the definition of derivative, we get the derivative of f of g of x is equal to the limit as h goes to 0 of f of g of x plus h minus f of g of x divided by h. We're going to multiply the fraction in our limit by g of x plus h minus g of x over itself. Since we're multiplying by something over itself, this is going to be multiplying by 1. It doesn't change the value, but it will allow us to do a few algebraic manipulations that will make taking the limit easier. The first of which being, we will rewrite the fraction so that we switch the denominators of the two fractions. G of x plus h minus g of x is now over h, and f of g of x plus h minus f of g of x is over g of x plus h minus g of x. We're doing this so that we get two expressions, two limits. One will be the definition of the derivative of f at g of x, and the other will be the definition of the derivative of g of x. So, to do that, we have to split this limit into two limits, and we do that. The right limit is, in fact, the definition of the derivative of g of x. The left-hand limit, if we can show that g of x plus h goes to g of x as h goes to 0, then this is the definition of the limit, the definition of derivative of f of g of x. And in fact, since g is differentiable, we get that g is continuous, and g being continuous implies that the limit as h goes to 0 of g of x plus h is equal to g of x. So this in fact gives us exactly what we were looking for, that our derivative of f of g of x is equal to f prime of g of x times g prime of x. Thank you for watching this video. My email address is mathjazz9@gmail.com. My website is almostcool.weebly.com. Feel free to email suggestions on future topics for videos, ask questions, inform me of errors in the video, or anything else you would like to email me about. I hope that you've been enjoying learning about calculus. I've been enjoying making this video. I hope you have a great day. Goodbye.